Okay, we're on page 5. Let's have you guys try a few before I show you this other one that's a little bit harder. So let's have you guys practice this number 1. You want to simplify. So you want to notice a few things before you start trying something. The worst thing you can do is probably change everything to sine, cosine in this case. But, that is also one way you can do to solve. So you see how you have a secant, cosecant, tangent, cotangent. There are 4 different functions. You got to narrow it down to at least 2 so you can solve it. Notice how they're all squares. So hopefully you remember some identities to help you simplify them. Okay, go ahead and do this. Let me know when you're done. Okay, most of you have the answer. Number 1, the answer is 2. So notice that you can use 1TS and 1CC for changing a lot of these to the other functions. So secant squared is the same as 1 plus tangent squared. And then cosecant squared is the same as 1 plus cotangent squared. Okay, so then minus tangent squared minus cotangent squared. That's all going to cancel, so you just have a 2. Okay, number 2. If you have not tried it, give it a try. This one, number 2, is just trying to see if you can do a manipulation on it. Okay, so 1 or 2 over cosecant x is the same as what? 2 sine x. So at the beginning of the chapter, we said 1 over cosecant is the same as sine. Okay, at this time, there's not much else you can do. But notice it goes sine squared, sine number. So then what this should remind you of is if you let y equal sine, you can kind of think of it as a substitution. This is like y squared plus y plus 1. Can you factor that one? Yeah? What does it factor to? In terms of y? Y plus 1 squared. And then you can substitute back. Of course, you don't have to use y. You can just factor it. Hopefully, eventually you see it quickly enough that you can just factor. And that's it. That's all you can do on this one. Okay, so this is where you just want to notice square, no square, constant. That's a trinomial that should recall, factoring. Okay, we're going to do the harder one together. This one. We need to simplify this one. This is on top of page 5. All right, what can we do? Common denominator, yes. And whenever you see 2 fractions, a kind of good thing to try is always common denominator. And a lot of times I don't get to the right answer right away. I try something, and as long as I try something, even if it doesn't work, at least I try something, and then I can try something else. You don't always get to the right answer right away, okay? And that's okay. This is cosine squared minus sine x times 1 minus sine x over cosine x times 1 minus sine x. That looks very crazy. Thoughts? What should we do? Distribute. Okay, so we should at least clean it up first. So a lot of times people try one thing and they don't see what to do and then they just want to give up. Don't give up. Just try something. Keep going. Okay, so we can distribute and then hope for the best. If you already see what to do, kind of wait for 5 seconds before the rest of the class, so then they can kind of think about it as well. Anyone besides the people who are like, I'm done? I said besides the people who are done. Besides the people who are done.
Can't you get 1 from cosine squared plus sine squared?
Yes, very good. Mark, you're going to be the person to wait 5 seconds. Okay, now we see it, right? I hope. This is like one step away from the answer. This cancels. 1 over cosine, so secant x. All right, good. All right, next, we're going to use these skills to help us solve some problems. I'm glad you're excited.
I love it. Like, it's so fun.
Yeah, it's very fun. Especially when you finish, you're like, oh, that
Yeah,
I feel very
yeah.
accomplished.
It's like you realize.
Yeah. Okay, so we need to find the value of x in this interval so that this works. So basically, the question is, what x will make this equation equal? Notice how this is kind of crazy. You have a cosine, you have a sine, and a cotangent. How are you going to find an x that works? We want to simplify it into something we can solve. So, thoughts? What should we do?
Okay, you guys can do
Change cotangent to cosine x over sine x.
Yeah, that's a good idea. We want to at least make sure that we don't have 3 different functions. We can change it to just 2 different functions. They look similar enough that maybe we can do something. What else? What's next? We need to solve. So hopefully solving reminds you of doing something. Whenever we solve in Algebra 2, we do what? Yes, make it equal to 0. That is definitely one thing we should always do. Make it equal to 0. Okay, they do have the same denominator, so maybe I can write it together. Now what?
Factor out cos.
Okay, very good. You can see that the cosines are repeating, so we can factor out the cosine. What else?
Cosine squared x minus 1 equals sine.
No. Okay, it's a little close, but not. Okay, so sine squared. Aaron's like, I'm dying to answer this. Okay, so we want cosine squared minus 1. Cosine squared minus 1. Huh? Not sine squared. Very close, though. Negative. Okay, so you can see that if I have to move this 1 to the left-hand side by subtracting, I have to move the sine squared to the other side by subtracting. So cosine squared minus 1 is negative sine squared. Oh, sorry, I forgot an x there. Oh, that's bad. Okay, cosine x times negative sine squared x over sine x equals 0. What else? Remember, we're trying to solve. We're not trying to manipulate as much as we can. Okay, what's going to make it 0? So if I just have 2 functions, one on the top, one on the bottom, which one being 0 will make the whole thing 0? Top or bottom? Top. The bottom's going to make it undefined. The top is going to be the one that's making it 0. We could have just solved at this part. We didn't have to go to the negative sine squared. Once you make it into a factor form, just make it equal to 0. The only way that whole thing is going to equal to 0 is the numerator equal to 0. But anyways, we got to the second part. Let's do the second part. Cosine x times negative sine squared x equals 0. We're in factored form. Factored form means something times something. If we're in factored form, make each factor 0. Cosine x equals 0. Negative sine squared x equals 0. The negative is negligible. It doesn't matter. We can divide everything by negative and it's gone. Okay, solve. Unit circle. This is why you got to memorize, or else this is going to take forever. Cosine of what is 0? Caleb just shrugged. Radians. Pi over 2. Huh? Not 0.
3 pi over 2.
Yeah, 3 pi over 2. Okay, sine squared equals 0. That means sine is equal to 0. What makes sine 0? Whoops.
Oh,
Huh?
is it 2
Oh, but 0 to 2 pi, so we don't include 2 pi. If you look at a question, there is like a parentheses on 2 pi.
Oh, then just 0.
Pi and,
Or just
pi and, yeah, 0. Pi and 0. However, let's go back to the original question. This is a little tricky. If you look at the original question, what's in the denominator? What's in the sine? So what does that kind of remind us? Yeah, sine x cannot be 0. Because if that is 0, it's going to make the denominator undefined. Therefore, the answer is just these two. Because the other one, even though we did solve it, it's going to make it undefined. So be careful when there is a denominator. When you solve, it cannot also make the denominator 0. Yes.
How did you get rid of sine x on the bottom?
I didn't. I just didn't care about it because in order for this whole equation to be 0, only the numerator needs to be 0.
Okay. Thank you.
Yeah. Okay, so this question has a lot of tricky parts. First, 0 to 2 pi. Only from 0 to 2 pi. Your answer is only from 0 to 2 pi, and see how it's not including 2 pi? So you don't want to have 2 pi as part of your answer. The second part is that there's a denominator, so you got to be careful and check. Okay, let's do one for practice. This one, find solutions within 0 to 2 pi. All right, what should we do first? Notice the things that are kind of obvious.
You can take out tangent.
Okay, take out tangent. Whoops. Square root 2 cosine minus 1 equal to 0. Okay, this is where you ask yourself, am I in factored form? Yes. Factored form means a times b equals 0. Right? I have something times something. Yes. This is not factored form because you have something plus and minus something. Does that make sense? That would be called a polynomial. Factored form is something times something equals 0. Okay, so I am in factored form. That means I will just solve. Yes, once you're in factored form, just solve. Okay, if you cannot see the difference between factored form and polynomial form, you got to ask because a lot of people have trouble with that, and you don't want to get to a point where you're solving for something when you couldn't. Tangent x equal to 0, we'll solve that later. Let's go ahead and solve this square root 2 cosine x minus 1. What should we do to solve for cosine x?
Add 1.
Yes, thank you. Add 1, and then,
Divide by
square root 2. But I don't recognize 1 over square root 2.
rational.
Yes, rationalize. So multiply by square root 2 over square root 2. I get square root 2 over 2. I've seen this before. Okay, let's go ahead and solve. Cosine x is square root 2 over 2. X is what? Pi over 4 and 7 pi over 4. Yes. Tangent x is 0. Remember, that just means sine is 0. Where is that? Sine is 0.
Pi.
Okay, pi, 0. All right, let's double check. Tangent may have a problem because tangent means sine over cosine. Is there any out of those 4 answers, is there anything that makes cosine 0? Because that's my denominator. So tangent x is really sine over cosine. That means I have a denominator. So I have 4 answers. Do any of those make cosine 0? It does? Where? No. Nothing makes cosine 0. Therefore, all 4 of them are my answers. Okay, I'm going to help you get started on the next one, and then you're going to finish it. Find all solution. Notice all solution, not 0 to 2 pi. So we're going to explain what that means. 2 sine x plus sine x equals 1. I need to solve. Notice the form is kind of interesting. What should we do first?
Subtract 1.
Yes, definitely. We should always make the equation equal to 0. Then what? Notice it's sine square, sine constant.
Make it like y equals.
Okay, so we can kind of do this on the side and say, let's say y is sine x, and then I can write this as 2y squared plus y minus 1 equals 0. So what's the reason for doing that? Yeah, factor. So we can factor. Once we factor, we're going to put sine back in. And now I have a factored form. I'm going to make each factor equal to 0 and solve. So go ahead and finish. Let me know when you're done. And we'll talk about what all solutions mean. Okay, this is 2y minus 1, y plus 1. So put that sign back in. You get 2 sine x minus 1 and sine x plus 1 equals 0. Make each part equal to 0. 2 sine x minus 1 equals 0. That means sine is 1/2. This is sine x plus 1 equals 0. So sine x is minus 1. Okay, solving that. Sine x equals 1/2. That means x is at pi over 6 and 5 pi over 6. Sine x is -1. That's only at 3 pi over 2. Once you get those angles, just double check. It says all solutions. That means you want everything possible in life, which means no matter how many times I turn, I should get to an angle like that. So that means you should have pi over 6 plus 2 pi n, 5 pi over 6 plus 2 pi n, and 3 pi over 2 plus 2 pi n. Everything has 2 pi n. The difference between all solutions and only 0 to 2 pi. So when you do homework or tests or things like that, make sure you just circle that keyword, all solution, or 0 to 2 pi. You don't want to miss something very small like that. Okay, if you have not given the next one a try, please try that and let me know when you have the answer. That will be the last one we do today, and then just do your homework.